Okay, friends, before we get too far down the rabbit hole of sampling bias and all that kind of stuff, I want to return us back to kind of where we took our left turn a few moments ago in the last video. The idea of why this class is called statistics. Basically, you're not going to get to measure the whole population very often, so you're going to be dealing with samples. And that sample data you collect is often numerical, quantitative, otherwise known as numerical data. Now, there are two general kinds. There's some that you can count, and then there's some that you can measure. And when you can count the data, it's called discrete, and when you measure it, it's called continuous. As best I can figure, data is discrete except if you're measuring time, distance, weight, or temperature. I believe those are the four categories, because those involve some kind of a sliding scale of a ruler that goes on them. For example, if you're talking about temperature, like when I left the house today, it was 36 degrees, and it's since warmed up into the 40s. Well, you know, when you start at 36, the next temperature up is not 37. There's lots, and when I say lots, I mean infinitely many temperatures between 36 and 37 degrees. And as I was editing that last video, I realized that it might help to stop for a second and understand why there are infinitely many temperatures between, say, 36 degrees and 37 degrees. There's also infinitely many distances between 1 foot and 2 feet. There's infinitely many weights between, 5 pounds and 10 pounds. And there's infinitely many seconds, I guess, between 0 minutes and 1 minute. Let's look at 36 degrees and 37 degrees. If the temperature increases from 36 to 37 degrees, it doesn't just jump. Like, it's not 36 and then it just becomes 37. It smoothly transitions between these. So there is, for example, a 36.5 degree mark between 36 and 37. There's also a 36.25 degree mark, and a 36.1/8, and a 16th, and a 36 and a 32nd, and a 36 and a 64th, and let's see how far down I can get, and a 36 and a 128th, and a 30. Now, this might seem ridiculous, but this is continuous data. What it does is it transitions smoothly from one to the next, and as I'm drawing that line, I'm passing through infinitely many little temperatures. Compare this to if I'm counting something like the number of, I've got this left over from the previous stat instructor. She left this little thing of candy corn. She's like, have your students guess how many candy corns in here. And I'm like, I don't want to do that. But we can count them, right? Like 1, 2, 3, 4, 5, 6. We can count them. But if I was to put this thing on a scale and weigh it, and then take a candy corn out, you would watch that scale change smoothly. It wouldn't just jump. It would change smoothly. And if we were to dump all the candy corn out and fill it with water, it would fill smoothly or increase or decrease, depending on if you're filling it or emptying it. So I just wanted to stop and talk about why, when you're talking about continuous data, there's no next number. There's infinitely many numbers between any two numbers on a continuous scale. That's all I wanted to say. So when you measure distances, when you measure weight, when you measure time, and when you measure temperature, you have some kind of a sliding scale ruler. Pretty much everything else is counted, how many of something. And we'll get into both, how to deal with both kinds of these as we go through the course. Now, moving forward, most of Math 243 is going to be what's known as descriptive statistics. What basically you collect a bunch of data and then you report back on that. And I do want to come back to this momentarily, but I want to contrast this with the primary goal of Math 244. And I'll stop talking so much about Math 244 tomorrow, I promise. But I do want you to kind of see where it heads, because the math of Math 244 starts in the math of descriptive statistics. Here is an example of a news report that I just pulled off of the Science News. Immune system mounts a lasting defense after recovery from COVID-19, researchers find. This is an example of what's known as inferential statistics, inferential stats.
Now what that is, and the word inferential, inferring, is the root there, makes predictions based on a random sample taken from the larger population. So when you see that headline, immune system mounts a lasting defense, at first it might sound exactly like that COCC article. But the difference here is when you look more deeply into this article, you see that there was an antibody response studied of 87 individuals. That's the sample. That's the sample. Now, the COCC article also mentioned the sample. They looked at 9% of the survey respondents. The difference between the COCC one and this one we'll get to in the homework. But the point is that this kind of statistics right here draws a sample, measures the sample, and then applies it to the general population. And that is kind of where Math 244 takes off. Generally speaking, in order to do what statisticians do, and they want the parameter. Remember, we talked about that earlier. They want to know the parameter. However, the best that a statistician can do is to get the statistic with a corresponding, what we called before, a margin of error. We spoke about that yesterday. Now, sometimes this is all, a lot of times you don't actually see the words margin of error in a study report. For example, here's an ad for Botox being used to deal with chronic migraines. But if you look at the bottom, you can see why this ad exists. Botox prevents, on average, 8 to 9 headache days versus 6 to 7 for placebo. Now, as we work through Math 243, you'll begin to look at ranges like that, and we'll be able to look at that 8 to 9 headache days and say, that means they had an average of 8.5 prevented headache days with a margin of error of half of a headache day prevented. Similarly for the placebo, same margin, but an average of 6.5 prevented headache days. And that's the entire range of the values right there. But I don't want to get too crazily far into inferential statistics. I want you to know enough about it for those of you that are not going to be taking Math 244, so that at least you go into the world knowledgeable of the limitations of a statistic. But I don't want to get too crazily far into it. So one more video and we'll look at some other ways of playing with the descriptive statistics world, the presenting of data.